Okay, here we go. Today we are going to be talking about compound inequalities with the OR involved. So at the end of the video, hopefully you can say, I can solve a compound inequality containing the word OR. So we are now talking about the OR parent today. So this would be the parent who says you can clean your room or do the dishes before you go out with your friends. So if we look at the graph of a compound inequality with the word OR, we're going to have two inequalities or two inequality graphs that form the compound inequality. So, for instance, if we take a look at this first top one, it says that x is less than a negative 2. So x is less than negative 2 would be an open circle with an arrow going to the left. And then it says, the second one says x is greater than or equal to a 1. If x is greater than or equal to a 1, that's going to be a closed circle at the 1 and an arrow going to the right. So now, if we looked at the compound inequality, x is less than or equal to a negative 2, or x is greater than a negative 1, we're talking about both of those pieces. So we're looking at the bottom part here where we got both of those pieces involved. Okay, so let's take a look. So if I said what compound inequality represents the phrase and then graph the solution. So if it says we want all real numbers that are less than or greater than or less than 0 or greater than or equal to 5. So what are we talking about? We would be writing this compound inequality. X is less than 0 or x is greater than or equal to a 5. So what would that look like for a graph? Here's what we'd have. We would have to have a 0 and a 5. This time we're going to have an open circle at the 0 and an arrow going to the left. And then at the 5, we would have a closed circle and an arrow going to the right. And that would be your graph. Okay. Next thing, what are the solutions of the inequality 3t plus 2 is less than a negative 7 or a negative 4t plus 5 is less than 1? So if we take a look at the first piece, these are actually easier to solve than the and statement because really we're just solving two inequalities, just the way we have been all chapter. So if I take a look at this first side, first thing I'd do is I'd minus a 2 from both sides. So I'd be left with 3t is less than a negative 7. Next thing that I would do, I would simply, no, not a negative 7, sorry, a negative 9. Next thing that I would do, I'd simply divide by a 3, and I'd be left with t is less than a negative 3. So that would be part of it. But we still have the other side here. Or, if I come over here and solve this one, I would subtract a 5, and then I'd be left with a negative 4t is less than a negative 4, and then I'd want to divide by the negative 4. And we have to remember that if you divide by a negative, we know we need to switch the sign, so it would be now t is greater than a negative, or excuse me, a positive 1. So your entire solution would be this last part here, where t is less than a negative 3, or t is greater than 1. So what does that look like on a number line? Well, we could put a negative 3 here, a 1 over here, and we'd have open circles at both of them. But at the negative 3, it says less than negative 3, so we're going to the left. It says greater than a 1, so we're going to be going to the right. Okay, hopefully that makes sense. Next one, I'm going to want you to pause the video, try and solve that one on your own, and then we'll come back and take a look at it together. Okay, so we should have this written down on our paper to start out with, and then we're just going to walk through it here. So we would minus a 7 from both sides, so I'd have a negative 3t is less than a negative 6. You should have divided by a negative 2, and that would give you y is greater than a positive 3. Or if we walk through and solve the other side, we'd minus a 3, and I'd get a 4y is less than or equal to a negative 8. And then you divide by a 4, and you'd get y is less than or equal to a negative 2. So what's that look like on a number line graph? Well, this time we have to remember which one's the bigger number, which one's the smaller number. I'd have a -2 on this side, a 3 over here. I know that at my -2, I've got a closed circle, and I'd have an arrow going to the left since it says less than or equal to -2. On the other one, we got an open circle at 3, and we'd have an arrow going to the right since it says y is greater than 3. Okay, next thing we're going to talk about again is this interval notation idea. We're going to look at interval notations specifically for the last case, the or statements. But let's just review it for a second. So for instance, if I had this first one, x is greater than or equal to a 2, we know on a graph that's a closed circle at the 2, arrow to the right. If we're looking at it at interval notation, we know a closed circle corresponds with a bracket. So we got a bracket of +2, and we know that it's going to positive infinity, so that's going to be a infinity sign with a parenthesis. So on this last one, where it says x is less than a -3 or x is greater than or equal to a 4, we'd actually have two interval notation sets with an or between them. So on the left-hand side, we know that we're going from a -infinity with a parenthesis to a -3 with a parenthesis, since there is no equal to with it. And then we just put the or between them. And then we have a little bracket because we got a equal to on the 4. And then that's going off to positive infinity. So that would be this part right here. So what we're going to be doing today as well is we're going to be writing some interval notation for and statements. So if we had y is greater than 7, let's just try thinking about what that would be on a graph, and then let's try and see what it would be in interval notation. So on a graph, I'd have a 6, a 7, and an 8. I'd have an open circle at the 7 and an arrow going off to the right. So if I'm thinking interval notation, I know that that's going to be a parenthesis, a 7, and where is it going to? It's going to a positive infinity. So that would be your interval notation. So with an or statement then, we're just going to have two sides of it. So if I have x is less than or equal to a -2, or x is greater than a 2, how can I write that or graph that? We're going to have a -1 on this side, a 2 over here. I know that at the -1, I'm going to have a closed circle and an arrow going to the left. At the 2, it's going to be an open circle, arrow going to the right. So what's it look like for interval notation? Interval notation, I know on the left-hand side, it was coming from a -infinity. So I'm going to have a parenthesis, -infinity. Where did it end? Ended at -1. And it has solid dots, so I know it's going to have a bracket. We got an or between them. And then this right-hand side, we start at 2. So I got a parenthesis, a 2. And it's going off to positive infinity. And we'd have another parenthesis like that. So this here would be the interval notation of what we started with. Okay. Hopefully that makes sense to you. That's all I have for today on this one. So that is a wrap.